One, two, three. Get caught on that every time. Good evening. This is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South. A very pleasant good evening on this 12th of September and 2025. As we come up to the grand final, we're all footy crazy. Some of us are, I suppose. And it's a good match on TV at the moment for those watching. Anyway, good evening, everyone. Trust everybody is okay and looking forward to the long weekend, to this weekend at least. We're competing against the over the horizon radar on 3541 at the moment, so hopefully my signal will be heard reasonably well on 80, but the over the horizon radar is fairly strong signal here, so my 80 meter transmissions may not be too good tonight. But we'll see, we'll persevere. We're also streaming on my YouTube channel, VK3CSJ. So just go to VK3CSJ and look for the live indicator. And also on my Discord HD channel. As I say every week, Discord is probably the way to go for being able to listen to me on 80 meters, for instance, and see the video to near enough real time, whereas YouTube is up to 20-second delay.
Anyway, doesn't matter. If you don't have Melbourne TV repeater, VK3R TV, which we're transmitting through it as well, then the two digital streams are the next best thing, since a lot of what I show here has graphics and pictures and sometimes video. There's no video tonight though. Once again, my downloader that I was using is playing up on me. It's weird. Anyway, that's another story. We also have an email address, vk3ekh@gmail.com, vk3ekh@gmail.com, which I'm just selecting the inbox right now. So if you wish to send signal reports of the like, you can go to that inbox, vk3ekh@gmail.com, which I'll check every now and then. In the meantime, we only have a few articles tonight, so if I can get by in under 60 minutes tonight, I'll be very happy about that. But in the meantime, this broadcast is on behalf of the ASV, the Astronomical Society of Victoria, and VK3EKH is the official call sign, and it's been broadcasting since 1988. So the Astronomical Society of Victoria was founded in 1922, has well over 1,600 members. Membership of the Society is open to anyone with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy, and to disseminate the knowledge of the science, and to provide greater facilities for the study among its members. Monthly meetings are usually held on the second Wednesday of each month, which was just gone last Wednesday. These meetings start at 8 p.m, usually held at the Maulia Hall, National Herbarium, in Burwood Avenue, Melbourne, near the Melbourne Observatory. Parking is available in Burwood Avenue, Dellisbrooks Drive and surrounding streets. Admission is free. Visitors are most welcome. The aim of the meeting is to try and finish by 10 o'clock. After the presentations, there's tea and coffee and bickies. Haven't been to a general meeting for quite some time. Usually they are streamed these days. They are now streamed on YouTube and Facebook. So if you can't make it into Melbourne. Privileges of a membership include the right to borrow books, periodicals and other publications from the Society's library located at Melbourne Observatory. Receipt of the ASV magazine Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory and after the monthly meetings, weather permitting. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. There's also a 200mm refractor, which is managed by the Royal Botanic Gardens, and a photoheliograph housed at the observatory and are accessible to members as well. The Society also has a number of 200mm reflectors available for short period loan in the ASV telephone loan scheme. Regular Society Club night meetings are held at Melbourne Observatory in the Ellery Suite, Burwood Avenue, opposite the Shrine of Remembrance. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. These instruments include a 508mm equatorial reflector and a number of smaller reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote, some 90 minutes drive north of Melbourne. There are a range of instruments available for members to use, the larger two with appropriate training, and they range from 300mm to 1000mm in aperture. Also located on the site is a fully steerable 8.5 metre radio telescope, which members can access via the radio astronomy section. Members are encouraged to make and use telescopes. Advice and help on both matters provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the society. Other areas of interest that members can participate in include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors are provided in the yearbook, and further information may be obtained by visiting the ASV website at www.asv.org.au. Notification of events are given in the Crux Extra Bulletins, which is an email sent out by the ASV every other week to keep members informed of what's happening. Please note that the ASV will conform to all government health directives, and certain ASV events may be required to be cancelled, moved or postponed. If you wish to write a letter to the ASV, you can send or address your envelope to the Secretary, the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001, if you wish to post a letter. Otherwise, the ASV is moving along in great strides. The observatory building that's going on out at Central Western Victoria is continuing at great pace, and these are going to be a series of roll-off roof observatories where you can hire an observatory and set up your telescope for as long as you like. You'll have to work that out, but the skies, from what I understand, the skies in this particular location are virtually Bortle 1, which means the sky is black and the stars are very bright. So that's the place to do astrophotography and some serious observing. So anyway, that's going ahead at great guns. There was an email that was sent out, and I did have it ready to read, but because I changed inboxes, that's now changed. I think that's it there. Yes. Just looking, this is actually a quick summary of the email that ASV send out, what they refer to as the Crux Extra Bulletins. It's a members' night at Melbourne Observatory tonight. Members' night at Melbourne Observatory, and the domes will be open, scopes will be out, and and always a fantastic chance to catch up with fellow members while enjoying the night sky. So that's actually at the Melbourne Observatory. Excuse my sniffing, but my nose is playing up. Although I don't know about tonight. I think the sky might be a bit cloudy over Melbourne. I think so. There might be some issues there. The ASV Library will also be open. This is tonight. The ASV Juniors section are also meeting tonight, so g'day to any of the ASV Juniors that might be listening to the bilge from here. And looking ahead, on Monday evening, the radio astronomy section meets via Zoom. So that's their usual monthly meeting time. And coming up soon is the Galactic Centre Party. Galactic Centre Star Party, I should say. The Galactic Centre Star Party, which is slated for September 20. And then there's the Sea Lake Astrofest, September 26 to 27. And then there is something called Wine Under the Stars, wine, pizza, telescopes, and the cosmos. And all that information can be gleaned from the ASV website. So there it is. All right, that's the Astronomical Society of Victoria. I'll go back to my inbox, vk3ekh@gmail.com, and there it is. All right. Super tired. Didn't sleep too well last night. Okay, first thing I have here is an article courtesy of astronomy.com website. As usual, I get a lot of my news from them. Oh, before I do, as you may or may not be aware, which camera am I on? I'm on that camera. I keep looking at the wrong camera. Let me go to this camera. I think it's a bit better. Yes, as some of you may know, earlier in the week there was a lunar eclipse. People like to call it a blood moon, but no, it was a lunar eclipse. Nothing particularly special about that. But I have found an image courtesy of Andrew, VK3KIS, although he passed it on from somebody off Facebook, I think. So I'm not too sure who took the picture, but if I can just find the damn thing, I'm pretty sure I brought it across to vMix. Maybe I didn't. In getting everything set up, I didn't bring it across, but I know where it is. So just bear with me a sec while I find the blasted picture. There it is. All right, have a look at this, ladies and gentlemen. Now that's the lunar eclipse on Monday morning. It started at about 1 o'clock-ish, and I think I was aiming to get to bed around about that time. And when I got up in the morning to go to work, I had a quick look out the door. It was probably about 6 o'clock, and there was only about less than 10% of shadow on the moon at that point. But that's a multiple exposure image of the entire eclipse. So what you see is the shadow of the Earth, the total shadow of the Earth, as the moon enters the shadow of the Earth and goes out of it. And of course the total eclipse is smack dab in the middle. I suppose it looks like a blood red moon. Yes, it looks like a blood red moon, but honestly, let's move on from silly terminologies. But nevertheless, there it is, and that's quite an impressive image of the eclipse. It looks like a band-aid, doesn't it? So as soon as I get my telescope up and running in the dome, I'll be able to do such things. Have to find out when the next lunar eclipse is. It's some way down the track, I think, here in Melbourne. So I missed an opportunity to do something myself, but it'll happen again. Lunar eclipses and solar eclipses happen quite a lot. So that's quite a good shot, though, isn't it? It looks like a band-aid. It really does. Anyway, there it is. That occurred Monday morning. I think totality was around 4 o'clock in the morning, and it was actually a clear sky here in Melbourne too. I half figured it was going to be cloudy, but it turned out to be fairly clear for the event. So folks were up and taking pictures, and there they are. There it is. There's one good picture. Thanks, Andrew, for sending that all to me. That's excellent stuff. Okay, first article, which has got this picture associated with it, and I'll bring that up. You may wonder what that is, and it's on September 11, 1985. It's the ICE probe. The ICE probe. It's called the ICE probe. So it was launched September 11, 1985. The ICE probe encounters comet Giacobini-Zinner. I think that's how you pronounce that. Comet Giacobini-Zinner. Today, that is the 11th of September, today in the history of astronomy, a spacecraft does a comet flyby for the first time. And launched as the International Sun-Earth Explorer 3 in 1978, a joint NASA-ESA mission, the ISEE-3 probe, studied the solar wind and the Earth's magnetic field from the L1 Lagrange point, which is a location. There's several of these Lagrange points that are dotted around Earth, where gravity is neutral between the gravity of the Sun and gravity of the Earth and Moon combination. Lagrange points are neutral little areas where you can park a satellite in a permanent type orbit around the Sun, and isn't affected by stray gravity fields, so to speak. Anyway, so the ISEE-3 probe studied the solar wind in Earth's magnetic field from the L1 Lagrange point. When its mission was complete in 1981, NASA proposed repurposing the craft by using it to intercept a comet. Such reuse would save money and time of building a new spacecraft. Renamed the International Cometary Explorer, International Cometary Explorer, which is ICE, was redirected through a series of lunar flybys, setting it up to intercept Comet 21P Giacobini-Zinner. Giacobini-Zinner, I think that's how you pronounce it. On September 11, 1985, the probe passed through the tail of the comet, approximately 4,885 miles or 7,860 kilometers from its nucleus. The spacecraft returned data on the making up of the comet's tail, supporting the theory that they are dirty snowballs. It was the first ever encountered of a human-made spacecraft with a comet. NASA continued to reuse ICE afterwards, flying it through the tail of Comet Halley in 1986. Though the agency ceased contact with the probe in 1997, an independent team of researchers called the ISEE-3 Reboot Project successfully re-established communication with the craft in 2014, firing its thrusters for the first time in 27 years. So that's all there is to that article, but I have to assume then that the probe is still active, and be interesting to find out whether it's doing any research as such. But yes, very interesting. It's interesting here too that they say that when they turned the spacecraft to go through the tail of the comet, supporting the theory that they are dirty snowballs, also helps support the idea that the comet or the asteroid or the object that exploded over Russia, the Tunguska event that it's known, was basically an ice ball that entered the atmosphere at a vast rate, and it exploded with great force that flattened the forest for many, many kilometres. But there was no evidence, apart from the mass destruction of the forest. There was no crater. There was no particles left in the ground, no evidence of a meteorite had broken up, which suggests that it was an ice ball, just a mass of ice that came in at such velocity that its shockwave, it just exploded under force, and the shockwave by itself was enough to flatten the forest and destroy quite a large number of trees. Yes. So anyway, that's an interesting one, that one. Okay, you're tuned to ASV Radio, VK3EKH, with the regular Friday night broadcast. And next article is also courtesy of astronomy.com. This is interesting. Have a look at this picture, ladies and gentlemen. I better have that here. Yep, there it is. Have a guess at what this construction is. Imagine having one of these in your lounge room. Okay. Laser makes more precise measure of Earth's wobble. Researchers refine one of our planet's motions with a single device. And in this picture, the title or the subtext to it is that in this picture, the picture shows the ring laser located at the Geodetic Observatory in Waldzell in Potsdam, Germany. All right, let's find out what this is all about. Recently, the results of a 250-day experiment to refine a particular motion of our planet was published in the journal Science Advances. Lead author Ulrich Scherber from the TUM Institute of Engineering for Astronomical and Physical Geodos, whatever that word is, in Germany. I'm saying that. Geodesy. Yeah, I think that's right. Germany said in a statement, "We have made great progress in measuring the Earth. What our ring laser can do is unique worldwide. We are 100 times more accurate than previously possible with our gyroscopes or other ring lasers. The precise measurement of the fluctuations helps us better understand and model the Earth system with high accuracy," they say. Yes, Earth wobbles. Earth's axis, the imaginary line that stretches from the North Pole to the South Pole, is not firmly anchored in the sky, as you might think by looking at a globe. Various forces act on it, causing it to wobble. The strongest influence is Earth's imperfectly shape. It bulges slightly at the equator compared to the poles. Also, the effect known as precession causes the extension of the Earth's axis to trace a circle in the sky. Currently, the northern extension points quite close to Polaris, the North Star, but where it points changes slowly during a cycle of approximately 26,000 years. So in the future, it will be aligned with other stars before returning to its current position. But the gravitational forces exerted by the Sun and the Moon, which sometimes reinforce or weaken each other, also pull on Earth's axis. This effect, known as nutation, causes small wave movements in the precession circle of the Earth's axis. This is a long-term nutation with a period of 18.6 years, but also many smaller ones with weekly or even daily fluctuations. As a result, the axis does not wobble evenly, but with varying degrees of intensity. The ring laser, in the picture you see here, the ring laser was able to measure all these effects directly and continuously over 250 days, with a level of accuracy previously unheard of for inertial sensors, i.e. sensors that operate independently of external signals. Unlike in the past, this does not require a network of several large radio telescopes on different continents. The ring laser can do all this on its own as a relatively small instrument located in an underground facility in Germany. In addition, the temporal resolution of the fluctuations is less than an hour instead of a day, and the results are available immediately, rather than after days or weeks, as in the case with other methods. The team added that with a further increase in the measurement accuracy and stability of the ring laser by a factor of 10 in the future, it would even be possible to measure the space-time distortion caused by Earth's rotation. This would give scientists a direct test of Einstein's theory of relativity. This would allow, for example, the lens-Thirring effect, or the dragging of space by the Earth's rotation, to be tested directly at Earth's surface. The lens-Thirring effect, LENSE, Thirring, THIRRING, the lens-Thirring, effect. Never heard of it, but there it is. It is the dragging of space by Earth's rotation. Fascinating stuff. That would be fascinating to measure that. So that was courtesy of astronomy.com, and the instrument looks rather interesting. I wonder how much money they poured into that project. But it is in Germany, so it's a precision instrument, you can be sure of that. You're tuned to ASV Radio, VK3EKH, where the time is 10:29. Next article is the birth of James Van Allen, not a guitarist. September 7 was the birth. September 7, 1914. September 7, 1914, the birth of James Van Allen. Today, that is the 7th of September, in the history of astronomy, the discoverer and namesake of Earth's radiation belts is born. And we have a picture of this fellow. If you have never seen Mr. Van Allen before, this is what he looks like. The article is again nice and short. James Van Allen, who was born in Iowa on September 7, 1914, showed a talent and an interest in science and math from an early age. That always helps. A major in physics from the Welsleyan College in 1935 was followed by a PhD in nuclear physics in 1939, before and after World War II, during which he developed anti-aircraft radio technology for the Navy. Van Allen worked in the Applied Physics Lab of Johns Hopkins University, and in 1951 became the head of the Department of Physics at the University of Iowa. On Jan 31, 1958, when the Explorer 1 satellite launched, it carried a Geiger counter and cosmic ray experiment designed by Van Allen. The data returned by Explorer 1 and subsequent orbiters led to Van Allen's discovery of the radiation belts around Earth, two donuts of charged particles trapped by our planet's magnetic field. The particles of the outer belt come from the sun, while the inner belt is created by cosmic rays interacting with our atmosphere. As the radiation could severely damage spacecraft, not to mention be hazardous to astronauts' health, Van Allen's discovery and his further research to the Van Allen radiation belts was a key step in the safe space exploration. He passed away in 2006 at the age of 91. James Van Allen. What a career that fellow has led. So, amazing fellow. Those were the days of great discoveries and interesting science and having your head screwed on properly, I think. Dear. All right. Next article. Courtesy of sciencealert.com. And there's a picture here. So, what are we looking at here, you may ask? This is the first ever elusive baby planet caught carving out cosmic rings, is the title. Published 12th of September. Today. So first ever elusive baby planet caught carving out cosmic rings. Alright, let's see what the article is saying. We've never seen anything quite like this. For the first time, astronomers have actually found a baby planet responsible for carving out gaps in the dusty disk surrounding a newborn star. Previous observations of such disks showed gaps, but the objects sculpting them remained elusive to our telescopes. The discovery of WISPIT 2b, that is WISPIT 2b, or not to be, sorry, the discovery of WISPIT 2b, 2 Bravo, as the exoplanet has been named, finally confirms long-held theories about how baby planets form and grow. It represents something of a game-changer for planetary astronomy. Actually, now scientists can flesh out their theories confident they are indeed correct. So in that image on the screen right now is the WISPIT 2 system, imaged using the ESO's Very Large Telescope. So it's a real image. We have another image here. This one. And that was imaged using the WISPIT 2 system, as imaged by the Magellan Telescope and the Large Binocular Telescope. The exoplanet is the blue blob on the right. Amazing stuff. So that's imaged by the Magellan Telescope and the Large Binocular Telescope. Oh, I must get a photograph of that. Be interesting to see how large that binocular telescope is. Anyway, so the blue dot is the exoplanet. Dozens of theory papers have been written about these observed disk gaps being caused by protoplanets, but no one's ever found a definite one until today. It's been a point of tension, actually, in the literature and in astronomy in general, that we have these really dark gaps, but we cannot detect a faint exoplanet that's in them. Many have doubted that protoplanets can make these gaps, but now we know that in fact they can. The process whereby stars and their planets are born is a complex one. First, a region in cold molecular cloud needs to become compressed enough that a large dense knot collapses under gravity. That's the seed of the star, or protostar. As it spins, material from the cloud around it is forced by angular momentum into a disk that feeds the growing protostar. Eventually, the protostar becomes so massive that the pressure and temperature in the core are high enough to ignite nuclear fusion. At the same time, stellar wind pushes the inner disk away, out of reach of the star's gravitational pull. What's left of that disk continues to orbit the star, clumping together to form the star's planets, asteroids and comets, which is how our solar system started. During this clumping together, gaps open up the protoplanetary disk. You know, just as an issue of that, I say that that's how our solar system started, and pretty much it would have been the same deal. You can see this in similar fashion by the rings of Saturn. If you study the rings of Saturn and the high resolution pictures that have been taken of the rings of Saturn, you can see how there are gaps in the rings of Saturn which are caused by the clumping of the material into small moonlets. And it's these small moonlets that are caught in this gravitational orbit around Saturn that's actually cleaning up the material inside the rings. And this is the same sort of thing, same sort of business going on here. During this clumping together, gaps open up the protoplanetary disk, which we see as rings around the star. The Akakama large millimeter submillimeter array, for example, has imaged many of these disks and the gaps herein. And here's this image, and this is also absolutely stunning image. This is a radio image. This is not optical, but these are all radio, photographed in the microwave region of the band. And the Akakama large millimeter submillimeter array imaged many of these disks and the gaps herein. This is a selection of protoplanetary disks imaged by ELMA. Planets in the throes of forming are particularly rich in hot hydrogen gas that emits a great deal of light called H-alpha. To detect this signature in the gaps in the protoplanetary disk, an international team of scientists designed a MAG-AOX, MAGAO-X, MAG-AOX, and an adaptive optics regime for the Magellan telescope. As planets form and grow, they suck in hydrogen gas from their surroundings, and as that gas crashes down on them like a giant waterfall coming from outer space and hits the surface, it creates extremely hot plasma, which in turn emits this particular H-alpha light signature. MAG-AOX is specially designed to look for hydrogen gas falling onto young protoplanets, and that's how we can detect them. The star TYC 5709354-1, now also known as Wispit 2, is a baby sun-like star about 434 light years away. Previous observations revealed a large disk around it with what researchers called a spectacularly large gap. They used the MAG-AOX to study a selection of stars, but it wasn't until WISP-2 that they got a hit. They got a hit. Finally, and what a hit! Combined with observations in near-infrared taken using the ESO's Very Large Telescope, the researchers were able to determine some key properties of the still-forming system. The protoplanet in Wispit 2b has gas giant about 5 times the mass of Jupiter. It sits in this particularly large gap, about 54 astronomical units from its star. That's 54 times the distance between Earth and the Sun. For context, Pluto orbits at 40 astronomical units. Right. It's an incredible discovery, one that reveals that our own solar system may have looked like as it was forming around a baby sun, which is what I was alluding to before, the researchers say. As such, it can give us an insight into not just system forming in general, but how our own little corner of the galaxy came into being. This is the first time, or the first ring-forming embedded planet we've observed. Let me just bring that picture back up again. Where are we? This one here. This is really good, this picture. This is what they're talking about. So this is the first ring-forming embedded planet star observed, giving the planet formation community a unique chance to learn more about the physics of planet-forming disks, especially how viscous they are, a key factor in how they spread over time and transport material and angular momentum. The system will likely remain a benchmark for many years, and this discovery has been published in 2 papers in the Astrophysical Journal, letters that can be found here and here. Of course, that's 2 links. Anyway, so there it is, and it's interesting to note that that little dot that's causing this gap in the disk is 54 AU from its apparent star, and that's like, you know, much further out than Pluto is in our own solar system. I tell you, it's amazing. We really do need to have a starship that we can travel to these places in the blink of an eye. It may happen one day, I don't know. Anyway, we can dream. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast coming to you from the studios of VK3 CSJ, who's desperately looking for his camera. And there I am. Okay, what's our next on the list here? All right, courtesy of space.com, and there's just one image here which I shall bring up right now. There it is. I think you'll all recognize this. Interesting article. I haven't read it right through yet, but let's see what they're on about. 108 million degrees. Solar flares are far hotter than thought, study suggests, published 16 hours ago. The new finding may solve an astrophysics mystery that has stood for nearly half a century. And the text that belongs to this image on the screen goes a bit like this. The strongest solar flare of 2025 erupts, or as Tamitha would say, poof. The strongest solar flare of 2025 erupts, causing a radio blackouts across Europe, Asia and the Middle East. New research shows that, or she actually says whoosh mostly, she says whoosh, but sometimes she says poof. New research shows that a flare particles can reach over 108 million degrees Fahrenheit or 60 million degrees Celsius, 6 times hotter than previously thought, underscoring the need for updated models to better predict space weather. I suspect that Tamitha knows all about that. Our sun's fiery flares are even more extreme than scientists had thought, blasting particles to temperatures 6 times hotter than earlier estimates, according to new research. Solar flares are colossal explosions in the sun's atmosphere that hurl out bursts of powerful radiation. These events are notorious for disrupting satellites, scrambling radio signals, and potentially posing dangers to astronauts in space. Now, a team led by Alexander Russell of University St Andrews in Scotland reports that particles in the sun's atmosphere heated up by flares can reach staggering 60 million degrees Celsius, tens of millions higher than earlier predictions, which typically put such temperatures between 10 million and 40 million degrees Celsius. And that's the end of the article. So there it is. So our sun is hotter than we thought. Who would have figured that? Anyway, it's just lovely stuff. Our scientists are studying. Where's my camera? Bring up my camera. There it is. What I'm hoping to do with my observatory, of course, is to capture something like this, to photograph the sun in great detail and capture a CME, either on video or a still image, or you can use a video. You can video and then capture frame by frame. I really do look forward to doing that. All right, what's next? I think we're nearly finished, actually. Oh yeah, this is a bit of a plug for the Mount Burnett Observatory. Okay, the Mount Burnett Observatory. I do have a slide here. There she blows. Come on. Mount Burnett Observatory. So, looking at the Mount Burnett Observatory, there's a special Halloween public viewing night on the 31st of October 2025 coming up. That's in October. So a special Halloween night on the 31st of October. I'm not sure what night that is. Let me just check my calendar and see what day that is. What is it? The 31st. It's a Friday, of course. Should have realised that. Alright, so that's a Friday. Special Halloween public viewing night, Friday the 31st of October 2025. So get in contact with Mount Burnett Observatory if you want to scoot up there and be a part of that. And on the 13th of September there's a members' night happening at the observatory as well. That'll be a Friday night too, no doubt. Anyway, Mount Burnett Observatory, making the wonders of astronomy accessible for all that live up in the hills. Looks like they've got a YouTube live stream channel now. You might want to check that out. That's interesting. A YouTube live stream channel that MBO now has. I didn't know that until now. But if you want to find out more information about what's happening at Mount Burnett, just go to the website at mbo.org.au. mbo.org.au. The Mount Burnett Observatory used to belong to the Monash University many years ago. Lots of good research has occurred at that observatory, and but it became not required by Monash University anymore, and is now fallen into the hands of a local community of astronomers, and they're maintaining and looking after the site. They also have a dome up there, a scope dome, I think it is, which I don't know what telescope is in that, but yeah, if you ever wanted to get into optical astronomy and you live in the hills, Mount Burnett is a good place to visit. I've been there a few times, did a presentation up there, a couple of presentations now, many years ago. Mount Burnett. What next is there? I think I'm coming up to spaceweather.com. Yes, was there something else here? Oh no, that's it. Yep, okay, that's it. Gee, we're going to finish on time. Alright, the sun. This is the disk of the sun as it looks right at this very moment. Oh, it's not a live image, but at least it's near enough. So there are all the current sunspots that are on the sun. Not many. 1, 2, 3, 4, 5, 6, 7, 8, I think. But that is the current disk of the sun. The coronal hole is like that. So there's a big black hole in the middle of the sun right now, which is streaming lots of charged particles out. In fact, I've got another image here which calls it the solar wind. How's that? That's probably a nice one. Solar wind. Okay. So go back to there. So the solar wind is currently at 374.2 kilometers a second at a density of 2.36 protons per cubic centimeter. The current sunspot number is 92, and the radio sun is at 115 solar flux units. That's measured at a wavelength at 10.7 centimetres, which closely correlates with the solar cycle, which looks currently like this. So if you're wondering where we are on the solar cycle, this is the current updated solar cycle together with the radio cycle. So you can see how the optical solar flare recording that goes on matches very closely to the information they achieve from the radio frequency at 10.7. Was it 10.7? Yep, 7.7 centimeters. Interesting stuff, that. When I was section director for radio astronomy at ASV, I wanted to actually set up our own radio telescope that tracked the sun specifically to measure the radiation at 10.7 centimeters. We never quite got around to doing that. We did have a dish installed ready to go, and all I wanted to do was try and come up with some receiver that will work at 10.7 centimeters. All these things would have occurred in general time, in all good time, but that's a project for some time way off into the future. But nevertheless, it would be interesting to try and capture this data at that same frequency and see if you can create your own chart that sort of mirrors what we're seeing here. That was the idea. Anyway, we're at like I've said in previous broadcasts, we're kind of at the 1 o'clock position on the solar cycle. Midnight is past, so we're on the decline. But that's not to say that there's still going to be quite a lot of solar flare activity over the next 12 months, which will make our HF bands sparkle. All right, this is the current aurora over the Antarctica. It's quite a decent active ring at the moment. Looking at my geochron screen, it's still about the same. This was taken about an hour ago on the screen here, but my geochron has an updated image and it's pretty much the same. So that is the current auroral glow. So if you're living in Tasmania, you may actually see a little bit of a subtle hint on the southern horizon. I think that's about it. The KP index, where is that? Here. The planetary K index is currently 2.67, which is considered quiet. And the 24-hour max is also 2.67, which is considered relatively quiet. So they're saying here that there is an off-target CME might graze the Earth. They say we wouldn't call it a fully fledged eruption, but on September 11, a magnetic filament in the Sun's southern hemisphere fluttered just enough to hurl a giant CME into space. The bulk of the CME will miss Earth, sailing south of the planet, but there is chance of a glancing blow at around September 14. Any impact would increase the disturbance already expected on September 14 due to the coronal hole described in the image you saw before. And they say in regards to the coronal hole, a butterfly-shaped hole in the Sun's atmosphere. A hole has opened in the Sun's atmosphere and it is venting a stream of solar wind toward Earth. NASA's Solar Dynamics Observatory photographed the 500,000 kilometre wide butterfly-shaped gap on September 11, which is the image you saw just a moment ago. This guy, that one there. All right. And I think finally, if I can get my mouse to work, potentially hazardous asteroids, PHAs. space rocks that are larger than approximately 100 meters that can come closer to Earth more than 0.05 AU. None of the known PHAs is on a collision course with our planet, although astronomers are finding new ones all the time. As of September 12, 2025, there were 2,349 potentially hazardous asteroids, but none of those we have to worry about. The only ones we do have to worry about are the ones we don't know about, and they're the ones that usually do enter the atmosphere and scare us to death with lots of dash cam footage and little bangs that make us wake up at 4 o'clock in the morning. Alright, that's about it. And let me find my camera. There we are. So thank you for listening to tonight's broadcast. I hope the woodpecker on or the over the horizon radar on 80 meters hasn't been causing anybody too much grief. I'm sure it has, though. It's pretty strong here. So, anyway, on the stream, I'm sure it's been good. Both streams are being held up nicely. They haven't fallen over. Let me just have a quick look at Discord. And there are Andrew, Cassiopeia, G'day Nebs, Mitch, VK3ZT, and David, our resident MBO member, is there. G'day guys, they're watching Discord. On email, do we have anything? No emails have come in. That's okay. And actually, Discord has a chat room. I don't usually check that chat room much at the moment because I'm focused on the video side of it. But Nebs Cassiopeia says hi everyone. Andrew says good evening to all. Scott, g'day Scott, VK3SMA. It's a good call sign. He says hi everyone. G'day Scott. David again, howdy. And amazing pick of yes, it is, wasn't it? Excellent stuff. Thanks, guys. All right. So, on that note, I don't think there's anything else I need to check. No. All right. I shall go across to 80 meters and see if there's any stations wishing to check in on this Friday night. All right. My pen's working. All right, this is VK3EKH listening on 3541 kilohertz.
Victor Kilowatt 3 Delta X-ray.
VK3 Tango Juliet Sierra.
This is Victor Kilo 3 Kilo Italy 0 VK3 KIS.
Okay, VK3 Delta X-ray, VK3 TJS, VK3 KIS. Was there anybody else there? Yeah, that over-the-horizon radar is pretty annoying, isn't it? All right, take it, Greg. VK3 Delta X-ray, VK3 EKH.
Yeah, good evening there, Clint. A good broadcast. Enjoyed it much, please. Got a chip in my mouth at the moment, and a beer in the other hand. So anyway, it's all been very interesting. I've got to ask the question. Is it an optical illusion? When I'm looking at you on YouTube, I look at all your columns on the shelf. Is there a bend in the shelf? Or is it an optical illusion? Good evening to Jack there and all the others that have checked in. Back over to you, Clint, for the answer. VK3EKH. Thanks for running it there, Clint. Great job, as per usual. VK3DX. Greg in Warrnambool.
On you, Greg. VK3DX. We're in Warrnambool. VK3 EKH returning. Well, I just had to look over my shoulder to check that because on camera I can see there is a bend, and it's not an optical illusion. There is a slight bend. There's a lot of stuff on that top shelf. As you can see, there's all the Collins stuff that's up there, and then there's an FRG7, there's a power supply here, Kenwood power supply and a speaker, and a trio, an RD, what is it, a 225 something? Forget its number, but a trio communications receiver, all valve communications receiver. So that's just enough to put a bend in that aluminium bit of square aluminium there. But there is no danger of anything falling, or else I wouldn't have that stuff up there like that. The issue I do have is when my black cat, Samantha, and she's sleeping on my chair over there at the moment, but Sam has been going through this phase of exploring how high she can go, and she's been all over this, and she goes to the top of the rack in this shot here, which you can't really see the top of, but if I tilt the camera up a bit, there, that's a bit better. You can see the top of the rack there. She goes to the top of the rack, and she'll sit up there like she's the queen of cats in all her domain. So anyway, but yes. Quite honestly, Greg, I don't know exactly what I'm doing here with this shack. I'm still trying to make up my mind about certain things, but I hope over the next 12 months, it'll probably take me 12 months, but hopefully I'll make up my mind whether I'm going to use this space behind me as a constructive, good-looking shack, or I'm just going to throw it all back upstairs again and turn the upstairs into a shack and turn this space behind me here into a bedroom. I don't know. You don't need to know those details. Anyway, but hopefully in time, the vision behind me from the camera's point of view will change and neat and tidy up a bit. But I guess to the ham radio community that's watching this, they might be very interested in the stuff that's behind me. There's a lot of stuff that's there. So yeah. Anyway, enough of that. All right, thanks, Greg. Enjoy your beer, mate. I've got one stubby in my fridge that's waiting to be consumed. Not tonight, mind you, but probably tomorrow night during the roast dinner that I'm thinking of cooking. Thanks, Greg. Back to you, across to you there, Jack, in Shepparton, and I believe there's a Shepparton, a Hamfest up at Shepparton this Sunday. So I won't be going to it, but if you're going to the Hamfest, enjoy the Hamfest. VK3TJS, VK3EKH.
Yeah, VK3EKH and the group VK3TJS. Good evening to you, Clint. Good evening to everyone that's joined the net, and certainly good to hear you guys, and good to hear the net again. I've had some visitors here, and we kind of not long ago they left, so I joined in a little bit late. But nevertheless, good to hear you guys. Good signal from you, Clint. 20 over as usual, no problem. Just a bit of that woodpecker, whatever it is, behind, but you're flattening it out quite well. Yes, that's right. Shepparton Hamfest on 14th. Everyone's welcome. It should be a good day. I think weather should be quite okay. And we hard at it, preparing for it, and my wife, myself, organizing the kitchen part of it. So the food should be quite good, with famous hamburgers as well, and we welcome everyone. So tonight, tomorrow, and in the morning we'll get up early and set the hall and everything else. That should be good. Clint, thanks for running the broadcast, and we'll catch up with you next time. Sorry you can't make it, but
It's
maybe
too
one
far.
day you will. VK3KH and the group VK3TJS.
Good on you, Jake. You're 30 over 9. Good signal coming in. And I think my audio level's up a little bit too high. 1, 2, 3, 4. Just knock that back a bit. 1, 2, 3, 4. So good signal from you. You're 30 over 9 down here tonight, so propagation's good. And fortunately, it's getting over the over the horizon radar, or woodpecker. Yeah, look, it's a bit too far. I mean, I find driving in the car for anything more than 2 hours just a bit tedious these days. The Subaru that I have isn't. It's not a pleasure to drive long drives. I get uncomfortable in the seat for one thing. It's just I start fidgeting. I start like, my hands are on the steering wheel, and I straighten up my back like this to try and straighten my back up because it curves, and I I'm not comfortable. And then of course I've got my eye on the temperature gauge because this Subaru has got a temperature issue, and once I start seeing the temperature gauge wafting around like that, I start to panic. So I'm afraid my time for doing long drives in this blasted Subaru that I've got is over. Okay, to go to work and coming home, or anywhere else around Melbourne, but otherwise, yeah, that's another story. Thanks, Greg. G'day. A very pleasant good evening to your visitors. Oh, excuse me, in your shack. I don't know if they're watching any video from me, but a very pleasant good evening to the visitors in the shack there. All right, next station is Andrew, VK3KIS, VK3EKH.
VK3EKH, VK3KIS, good evening, gents, and all the group. Hope everyone is keeping warm. Just disappointing observation, weather. We've got to observations with it for the last couple of days. Just been disappointed with that. But the gyroscope for checking the German gyroscope for checking the wobble of the Earth, I was quite fascinated by that. And I'm assuming, yes, that's the one. I'm assuming they can detect some way of those lasers moving out of alignment because of the wobble of the Earth. And just wonder how that works. Anyway, thanks for doing it. We'll do it again next week. VK3EKH, VK3KIS.
Yes, unfortunately the article didn't go into any technical details, did it? But I suspect it would be a very similar sort of thing that the LIGO gravitational lasers, how the gravitational lasers work, or with LIGO, with the gravitational lasers, that's over a kilometre or 2 kilometre stretch, whereas clearly this is not that. It looks like there's four, or maybe, I don't know, I'm not really sure how it's done, but it looks like there's four, potentially, there seems to be 4 tubes, maybe more, and it looks like that there's like a prism, some sort of lens or prism at the crossroads, and you can see that there's some sort of a monitoring device there. So it's obviously firing some laser that's been probably creating an interfering field, something akin to interferometry, perhaps. And they're looking at changes in the fringe created by the laser of some sort. But yeah, unfortunately the article didn't go into any detail on that. In fact, there might be something more on Wikipedia. I might see if they've got more detail of this device on Wikipedia, because I'm sure Wikipedia will have something, and no doubt in more detail. Maybe. Anyway, we'll do a little bit of research on that, and maybe something for next week. All right, thanks, Andrew, and also thanks again for the image there of our lunar eclipse. That's really quite an amazing image, that one, for sure. I'll do that one day myself. Anyway, all right. Is there any other stations wishing to check in? VK3EKH listening. Yeah, that over the horizon radar thing is really annoying. All right, on that note, thanks, ladies and gents, for tuning into tonight's session, this 12th of September. And I think the grand final is still 2 weeks away. So the 26th of Friday is the public holiday here. So, yeah, another 2 weeks for their grand final. Anyway, I won't worry about that right now. All right, cheers everyone. Take care. Have a very pleasant weekend. And if you're going up to the Shepparton Hamfest, enjoy the trip and come back with many goodies. This is VK3 EKH, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast coming to you from the studios of VK3 CSJ in Narre Warren South, concluding for tonight. And that reminds me, just before I do, last Wednesday was the Astro Talk, the ASV's Astro Talk on jellyfish galaxies. I haven't had a chance to sit through that yet, but it is available to watch on YouTube. If you go to the ASV's YouTube channel, the Astronomical Society of Victoria's YouTube channel, the latest video that they've uploaded and made available is from last Wednesday's Astro Talk, and it's called the Search for Jellyfish Galaxies, an ASV presentation, and it's presented by a Dr. Jacob Crossett. He is an astronomer and researcher who studies how galaxies transform, including search for rare jellyfish galaxies. He completed his PhD in astrophysics at Monash University and has since worked in the UK and Chile, using some of the world's largest telescopes to study these unique objects, including the VLT and Magellan. Jacob is also passionate about sharing his love for space through public talks, telescope evenings, and citizen science projects. So yes, last Wednesday night he gave a presentation understanding the evolution of galaxies in dense environments, i.e. the search for jellyfish galaxies. I've never heard of the term jellyfish galaxies before, but there it is. And that's all available to view right now. I tried to download it before, but I was having trouble, so I can't do anything with it at the moment. Anyway, but it is there on YouTube to go and view. Cheers, everyone. Take care. This is VK3 EKH, concluding tonight's session. Cheers, everyone.